Let us study the concept of centrifugal force. Now, to understand the concept of centrifugal force, there are few important points you need to understand. The very first point which all of you are aware is circular motion is an accelerated motion. We have already studied in detail that in circular motion, velocity vector of particle continuously changes and circular motion is an accelerated motion. Next point related to this, which also you know but you need to understand it here, a reference frame moving in a circular path will be a non-inertial reference frame. Obviously, as circular motion is an accelerated motion, we can state that a reference frame moving in a circular path will be a non-inertial reference frame. Like if we consider a simple circular motion, say there is a body which is connected with a string. One end of the string is attached to the center of circle, one end is attached to a body, and say body is thrown with a velocity vector v. So body is in a circular path which is tied up to the center with the help of a string. If we build it in a circle, we can simply state for its circular motion, tension will provide the necessary centripetal force. But if the same situation we analyze by considering ourselves sitting on the string, or you consider an observer who is sitting on the string in the neighborhood of this body and also revolving at the same speed in the same circle, or you can say the observer who is also revolving in the same circle with the same speed along with the body, when this observer will observe the body, he will feel that the body is at rest. Obviously, if all the motion parameters of body and observer are identical, the body will be at rest relative to this observer. If we talk about this observer is also moving tangentially with the same velocity v. So this observer will also have an internal normal acceleration or an inward normal acceleration, that is v square by r, if r is the radius of the circle. In this situation, as observer is having a normal acceleration or a centripetal acceleration in inward direction, when this observer will look at the body, certainly as observer is non-inertial, he'll feel that a pseudo force is acting on the body in outward direction. And the magnitude of this pseudo force can be written as mass of body into acceleration of observer, that is v square by r. Actually, this mv square by r here is the pseudo force which appear to act on body with respect to this observer. Once again, let us discuss. As observer is in a circular path, observer is having an radially inward acceleration v square by r. Because of acceleration, the observer will be a non-inertial reference frame. And with respect to this observer, we can say every body in surrounding will experience a pseudo force. The magnitude of pseudo force is given by mass of body into acceleration of observer in the direction opposite to the observer acceleration. So observer will feel that this body is experiencing an outward force, that is mass into acceleration of observer, this is mv square by r. This force we term as centrifugal force. Don't be confused with this force as centripetal force. This observer will not observe centripetal force acting on body, because with respect to this observer, body is not in circular motion, and centripetal force appear to act only on those bodies which are in circular motion. So here, as the body is at rest, if we draw the free body diagram of body with respect to a revolving observer. You can simply state with respect to this observer, the body will experience a tension and a pseudo force in outward direction, that is mv square by r, and the body appear at rest with respect to this observer. If the body is at rest, the forces must be balanced. Here T can be written as mv square by r. The two are balanced in the reference frame of this observer we are talking about, which is rotating or revolving. This is a rotating observer. So always remember this concept when you observe a body in circular motion from ground frame or from outside of this circle. You can say the body must experience some centripetal force because of which its velocity vector is changing. But when we observe a body in circular motion with respect to an observer which is also revolving along with the body will appear to be at rest, but body will experience an outward centrifugal force, or which is a pseudo force. We can say that centrifugal force is not a real force. It is a pseudo force which appear to act only on those observers, only on bodies with respect to those observers which are also revolving along with the body, and whenever centrifugal force appear to act, the body will appear to be at rest. So dear students, always remember whenever you apply centrifugal force on a body in circular motion, you always need to balance the forces acting on body. This is always a comfortable method to handle problems related to circular motion. Let us write once again about centrifugal force. Always remember it is quite an important concept. We'll also take up some example about centrifugal force. You can write that it is a pseudo force. Next point you can write about it is it appears to that observer which moves in circular path along with the body in circular motion. Next point you can write it appears to act in radially outward direction and its magnitude can be given as mv square by r. So many students get confused that centrifugal force act in radially outward direction, its magnitude is mv square by r, and centripetal force act in radially inward direction, and that is also having magnitude mv square by r, and they'll get balanced. This is a misconception because centripetal force appears to that observer which is looking at the body in circular motion from outside the circle and who is at rest. And we can say centripetal force is the real necessary force which is required for a body to circulate. And centripetal force is a false force or a pseudo force which appear to act on body only to that observer which moves in circular path along with the body in circular motion. So be careful, both the forces centrifugal and centripetal never appear to act simultaneously. Let us study the analysis of conical pendulum by using centrifugal force. As we already studied about conical pendulum, it is a simple pendulum revolving in a horizontal circular path in such a way that the string of pendulum describes a cone. We already studied that in case of conical pendulum, the pendulum bob experiences two forces, one at its weight in downward direction, that is mg, and the other is tension in a string which act along the length of the string. Now, if this bob is observed by an observer which is also revolving along with this circular path, we can say that observer will experience that this body is experiencing an outward centrifugal force, and this centrifugal force will be mv square by r. But this force will be felt or experienced only by the observer, that this is acting on the body. Now, if observer is revolving with the same speed along with the body, he will feel that the body is at rest. And that observer will feel that the body is under the influence of three forces, mg, t and centrifugal force. And as the observer will feel that the body is at rest, then to analyze the motion, we need to balance all the forces acting on it. If this angle is theta, the upward component of tension will be T cos theta, and the horizontal component of the tension will be T sin theta. So we can simply state, if we draw free body diagram of bob as seen by an observer in rotating reference frame, we can simply state bob will be experiencing a force mg in downward direction. It will experience centrifugal force mv square by r toward left, and the tension in the string it will experience along the length of the string. Here if theta is the angle, we can simply state in upward direction its component is T cos theta, in horizontal direction it is T sin theta, and the body will appear at rest with respect to this observer. So we can simply state in rotating reference frame, as body is at rest, we use T sin theta is equals to mv square by r, and we use T cos theta is equal to mg. You can see we are getting the same two equations which we have obtained while analyzing the conical pendulum with the help of centripetal force in ground frame. Here we are analyzing the same situation with respect to a rotating observer or rotating reference frame. We are getting the same equations. Combining the equations will get the same relations, like on dividing we get tan theta is v square by rg, and squaring and adding the two we get tension is equals to m into root of v4 by r square plus g square. From here you can also get the value of speed of particle, that will be root of rg tan theta. So be careful about this analysis. It can be handled either in reference frame of ground. In that situation we need to use the analysis of centripetal force, but if we analyze the motion with respect to an observer which is revolving along with the body, in that case we use centrifugal force and we consider body at rest. So we need to balance out all the forces.